Hello. We're going to be talking about logarithmic functions. Logarithmic functions are the inverse functions of exponential functions. And that's why whenever we talked about exponential functions, we said they are one-to-one, meaning they have an inverse relationship with another function, and we call them logarithms. So, just looking at our basic exponential function, we said it was f of x equals a to the x. A is my base. So just coming up with a function saying f of x equals 3 to the x, let's write the inverse. We'll replace f of x with y, so I end up with y equals 3 to the x. Now interchange. Now this is where it kind of gets different. It, to turn around and write it to where y equals, they developed a way to turn around and word it. And it makes sense whenever you read this. Y equals the power, because y is a power, to which you raise 3 to make it equal x. Well, instead of writing all of that out that way, they just gave it a name. And so what this turns into, whenever I interchange and then I'm going to solve, is I just simply say y equals log base 3, right, base 3 of x. So y equals the log base 3 of x. And what that says is the logarithm base 3 of x. Again, log base 3x means the power to which you raise 3, so the power to which you raise 3 to get a value for x. So what this example here shows you is that the inverse of f of x equals a to the x is given by the inverse of x is equal to the log base a of x. So let's look at the log base a. Y equals the log base a of x, and it's defined as the number y such that whenever x equals a to the y power, where x is greater than 0 and a is a positive constant other than 1. And properties of logarithmic functions, I'm going to slide this in here, or properties of exponential functions. Slide both of those over. Continuous, continuous, one-to-one, one-to-one. And notice though that my domain and range are interchanged. My domain for my exponential functions was all real numbers. Well, now my range is all real numbers. My range for exponentials was from 0 to infinity. Now my domain is from 0 to infinity. My horizontal asymptote was the x-axis. Now I have a vertical asymptote, which is the y-axis. My y-intercept, well, now I have an x-intercept of 1 comma 0. These are the properties of your logarithmic functions. So before we go into graphing, I feel we need to be able to look at converting logs and understanding how we come up with values. That way you can plug something in, you know what to get versus just using the calculator. We'll be able to look at that. But I do want to show graphs. So we'll go to Desmos, and here we have some graphs. All right, so the exponential is for this graph. The inverse of the exponential, so I just wrote it in inverse form. And then I wrote it as a logarithm, which is the inverse of this exponential. And I have a couple of them that we can look at. So the first thing I want to look at is the exponential graph. And we already saw this in the previous video. Okay, so I know there's my y-intercept, it's continuous, the x-axis is the horizontal asymptote, that it is one-to-one, the domain is all real numbers, the range goes from 0 to infinity. Now, just looking at it is the inverse. That is my inverse. That means everything would interchange. My properties for my exponential function y equals 1.1 to the x would interchange with x equals 1.1y. So my exponential function is in purple. My inverse of the exponential is in blue. I want to click on this and show you. See how that blue turned to red? That is typed in as a logarithm. Y equals log base 1.1 of x. See there's my x-intercept 1 comma 0. My y-axis is my vertical asymptote. My domain is from 0 to infinity. My range is all real numbers, and it is 1 to 1 as illustrated. One thing I also want to point out is there's my line of symmetry between my inverse function relationship. Y equals x. They're symmetric about that. I'll remove that. And see, I will show this again. It's the same graph. Same graph. Either written as the inverse of the exponent or typing it in as a logarithm. Okay, so there's the first set. Here's the next one. My exponential function is y equals 5 to the x. There it is graphed. The inverse of that, I interchange x and y. Is that? I'll go ahead and put in my line of symmetry. There's my line of symmetry. They're symmetric about that. But I can retype x equals 5 to the y power as a logarithm. Because what that turnaround says is this right here. It says the exact same thing. It's saying y equals the power to which you raise 5 to get x. So I just type it in as a logarithm, and that green line changes to a purple line. So typing it in, this is the logarithmic function is nothing more than the inverse function of the exponent. And you can see that it's 1 to 1 because of the symmetry about y equals x. Okay, so that is a view of exponential functions. To graph exponential functions and to do it by hand, again, we need to make sure that we need to look at converting logs and some rules with logarithms. So we'll cover that later on. As for right now, please watch your publisher's videos. Critically think and structure your homework. Make sure that you have these properties down just like you have the exponents. What's nice is that it is the opposite of each other. And good luck on your homework.